The somatic motor, sympathetic, and parasympathetic divisions differ in their anatomy, neurotransmitters, and receptors. Anatomy. The somatic motor division consists of a single neuron that extends from the central nervous system, CNS, directly to skeletal muscle. Both sympathetic and parasympathetic divisions are part of the autonomic nervous system, ANS, and use a two-neuron chain. A preganglionic neuron with its cell body in the CNS, and a postganglionic neuron whose cell body is in an autonomic ganglion outside the CNS. In the sympathetic division, preganglionic neurons originate in the thoracolumbar spinal cord and usually synapse in paravertebral, sympathetic chain, or prevertebral ganglia. Postganglionic fibers tend to be long. In the parasympathetic division, preganglionic neurons arise from the brainstem or sacral spinal cord and synapse in ganglia close to or within the target organ. Postganglionic fibers are short. Neurotransmitters. The somatic motor division uses acetylcholine, ACH, as its neurotransmitter, released at the neuromuscular junction. Sympathetic preganglionic neurons release ACH, while most sympathetic postganglionic neurons release norepinephrine, noradrenaline. Some specialized sympathetic fibers, like those to sweat glands, release ACH. Parasympathetic preganglionic and postganglionic neurons both release ACH. Receptors. In the somatic motor division, ACH acts on nicotinic cholinergic receptors, specifically the muscle type, on skeletal muscle. In the ANS, AH released by preganglionic neurons, both sympathetic and parasympathetic, binds to nicotinic cholinergic receptors on postganglionic neurons. In the sympathetic division, norepinephrine released by postganglionic neurons acts on adrenergic receptors, alpha and beta subtypes, on target organs. Exceptionally, ACH released by some sympathetic postganglionic neurons, e.g. to sweat glands, acts on muscarinic cholinergic receptors. In the parasympathetic division, ACH released by postganglionic neurons binds to muscarinic cholinergic receptors on target tissues. In summary, the somatic motor system uses a single neuron and cholinergic signaling at nicotinic receptors, while the autonomic system uses a two-neuron chain with cholinergic transmission at ganglia and either adrenergic, sympathetic, or muscarinic cholinergic, parasympathetic receptors at target organs.